So let's say we are going to mix some things together. Okay, so I am going to make trail mix to bring in class. Okay, and I have let's say 2 gallons of trail mix I'm bringing to school. If I told you it was 50% M&Ms, how much M&Ms? A gallon. So if I have 2 gallons total and it's 50% M&Ms, 1 gallon is M&Ms. Okay. If I were taking this, let's say we're going to make punch. Okay, we're going to mix Kool-Aid and 7-Up. And I told you it was going to be 25% 7-Up, and we made 4 gallons of punch. How much 7-Up do I need? 1 gallon. On those types of problems, what you're doing, you knew the amount of the total. So you did the amount times the concentration. So 50% to 25. And that gives me the amount, I call it the amount pure, the amount of whatever I'm looking for, the amount of M&Ms, the amount of the 7-Up, those kinds of things. With these problems, they can get a little more complicated than just, nice whole number answers, where I'm just mixing 2 things. I might be mixing 2 different kinds of punches together. So this one was 25% 7-Up, and this one is 30% 7-Up, and I need to figure out in my total. So when we have a lot of information like this, the strategy I suggest is making a table, and that's what I'm going to do on all these problems. We're going to work through several, and you're going to see every time we set them up exactly the same. So the first one may seem a little weird, but once we do the second and the third, it is the same thing every time on here. So here is my first example. I apologize, it's a little small. Can you guys see it? It says, how much pure alcohol should be added to 20 liters of a 40% alcohol solution to increase the concentration to 50%? Okay, so I'm taking a pure and I'm mixing with the 40% to get a 50%. Think about all your chemistry experiments, okay? Sometimes you may have to mix different solutions together. So what I'm going to do is set up a table. I'm going to put that formula across the top. The amount times concentration equals the amount pure. That's my formula. Those are going to be the columns of my table. My rows are going to be the things that I'm mixing together. So you can label these rows however you want. Some people just do like the first, the second, and the total. Some people are a little more specific. We're mixing the pure with the 40% to get the 50%. I don't really care about those labels on the row, just as long as it helps you understand what's what. Okay, so now we have to fill in the blanks. So it starts out, how much pure alcohol? So do I know the amount of my first one? No, so that's my X. Concentration, this is my percent. If it's pure, what percent is it? 100. If you're going to put a percent in a problem, what do you have to do to it? Yeah, we have to put the decimal. So you always move your decimal back 2 places, so 100% would just be a 1. Should be added to 20 liters of a 40%. So the amount of my 40 is 20. The concentration, 40%, would be 0.4. to increase the concentration to 50%. So the concentration on my total is 0.5. Okay, I didn't give you the amount of the total. So let's see if we can figure that out. What I do anytime I get stuck is I go back and I think about numbers. So let's pretend if I had 30 liters of the first one and 20 of the second one, how much do you have in the total? 50. How did you get that? Add them. So if I have x of the first and 20 of the second, then we have x plus 20 in the total. So then we just multiply amount times concentration. So we're using this formula. It says you multiply, so I'm doing the 1 times the x. 0.4 times 20. The 0.5 times my x plus 20. You can go ahead and multiply those if you want. I'm just writing it like this, so when you're looking in your notes, you can see exactly what I did. I just followed the formula across the top. Once you get to this final thing, the equation kind of writes itself. This tells me the amount of alcohol in the first one. This is the amount of the second one. This is the amount in the total. So what should we do to those things? Add them to equal the total. So I do the first plus the second equals my total. And so then that's just a linear equation like we've been solving all week. So we have x plus 0.4 times 20, 8 equals 0.5x plus 10. Subtract my x, 0.5x over. Subtract my 8. Divide by 0.5. And we get x to equal. Am I done? No. I said yesterday you have to always define your variables and answer in a sentence. Now the defining my variables, if you have this table and you've labeled your columns and rows, then I know what your variables are. So that is defined. When we write our sentence, we have to make sure we answer the question, and it was just how much of the pure alcohol. When I look in my table, x was the amount of the pure one, so that is my answer. So there should be 4 liters. Questions on that? Let's do so the setup is going to be the same every time. How many liters of 25% antifreeze should be added to 5 liters of a 10% solution to obtain a 15% solution? So we set up our table. These mixture problems, the same formula goes across the top every time. The amount times the concentration equals the amount pure. my rows. You can call them however you like. One hint I want to give you, even without reading the problem, you should be able to look at these percents and know which one are the ones you're mixing together and which one's the total. You will always mix your highest and lowest concentration to get something in the middle. You know, I can't mix something that's 5% and something that's 10% and get a 30%. That's impossible. If I'm mixing 5 and 10, I can only get 7, 8, or 9, something in between them. So if I just looked at 25, 10, and 15, which one's my total? The 15 has to be my total. So that's a good hint to help you. So we are mixing the 25% and the 10% to get that. So I can fill in my concentrations. For 25% we would do 0.25. For 10% we do 0.1. And for 15% we do 0.15. So you just move your decimal back 2 places. So do I know the amount of 25%? No, it says how many liters of 25, so I don't know it. That's my X. How much 10% do we have? 5. Should be added to 5 liters of a 10%. To obtain a 15%, so how much do we have in the total? X plus 5. Okay, once you fill out that part of your table, you've kind of done all the hard stuff. What would I do next? Multiply across, so X times 0.25. Your 0.1 times your 5. 0.15 times your X plus 5. So you can go ahead and multiply those now. You can leave it and multiply them in a second. That part doesn't matter. So when we write the equation, what do we do every time? Yeah, the equation just comes from this last column. You said add the first two to equal your total. Solve that equation. So our X is 2.5. The question was how many liters of 25%? That's what my X is. So you write a sentence. You guys ready to try one on your own? This is your problem. Which things are you mixing together? it looked like you guys got tripped up on the concentration part. It starts out how much water. So what would I put there? Should be added to 20 liters of an 18% acid. So my amount is 20, my concentration is 0.18. To reduce the concentration to 15%. So where does the 15 go? Total concentration. What would I put here? X plus 1. Okay, so let's talk about this concentration. We're talking about the concentration of acid. So if you go get a drink out of the water fountain, what percent acid is that water? 0. We really hope so. Pure is 100%. Water is always going to be a concentration of 0, whatever mixture we're looking at. So then we just multiply. So we have x times 0, which is 0. 20 times 0.18. 3.6. Years of experience. And then our 0.5 times the x is 20. So then we always add the first two to equal the total. So we get 3.6 equals 0.15x plus 3. Subtract your 3. Divide by the 0.15. And x is 4. So we should have 4 liters of water. Is this okay with everybody? I would like to do one last example if that's all right. So this one is just slightly different because I'm not just creating a mixture this time. So Sarah has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe, government-insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of her money in non-insured corporate bonds paying 12%. How much should be placed in each investment to achieve her goal? So you guys did problems like this in Algebra 2, but you usually did systems of equations with it, and that works just fine. I just wanted to take a problem that you've done before and show you how to use the tables to solve this and help organize your information. So just giving you another option. We have several things going on here. She's going to put some of her money at 8%, or at 8%, some of it at 12%, and then she has her grand total. So those are my rows. Okay, and again, the rows you can label however you want. You can call it first, second, total. You can call it the percents if you want. You can call it, the CD and the bond. I don't care. But the formula across the top, this time it wouldn't make sense to do an amount times the concentration, would it? If you're talking about interest, what formula do we use? Remember, principal times rate times time equals interest. You have used that one before, but it's probably been a little while. So we are going to put our interest formula across the top here. Principal times rate times time equals interest. Okay, so let's read through our problem. She has $70,000. That is her starting amount. So is that principal, rate, time, or interest? P, your principal. Is that the amount in the first investment, the amount in the second, or her grand total amount? Total. What interest rate does she want for that total? 9%, so my rate would be 0.09. Okay, so in my first one, we're going to invest. Does it tell us how much? So we'll call that our X. My rate is 0.08, 8%. Okay, and the next one, she's going to put some in the bonds that pay 12%. So that rate is 0.12. Did it tell me how much I put in that one? No. I can't call that X again, because I didn't say she put half of her money in each. So let's think about it. If you put $10,000 in the first one, and you had $70,000 altogether, how much did you put in the second? 60. How did you get it? So this will be my total, the 70,000, minus the amount you've already used, minus your X. Does it tell me how long she's investing it? No. So if the problem doesn't tell me otherwise, we will just assume 1 year. So then we multiply principal times rate times time. The formula at the top was different, but the equation is going to be the same. It comes from this last column, and all you have to do is add the two things you're putting together, so add your two investments to equal the total. So then we just have a linear equation. $52,500, is that right? So then we have to answer the question, which was how much should be placed in each investment. Okay, so the $52,500 is the amount at 8%. To get the second amount, my 12% is 70,000 minus X. So 70,000 minus that . 17,500. questions on that one? We will start tomorrow with another one of these, so there's not any of these on your homework today. Today's assignment, it's all just those problems like the 3 we did, the mixture problems. So you're back to the handout from yesterday, and for tomorrow